following functions bounded above, below, anything like this. So this is an exercise in kind of quantitative reasoning more than anything else. X squared. What about x squared? So let's just think through. So bounded, it's all to do with the range, right? It's the output of the function. We need to understand what the output of the function is. And I'm not going to do this using the graph, even though it's very nice to visualize things with the graph. I want to think quantitatively. So x squared. For x squared, of course, if I was allowed any x, it would certainly be bounded below for sure by 0, right? Because any number squared is positive, or greater than or equal to 0. But it's not bounded above, because I could choose huge x and then x squared would get massive, right? And there'd be no upper bound on it. But I'm not doing that. I'm only allowing x to be between 0 and 10. So this is bounded, kind of bounded below. By 0, of course. When I say bounded below, I mean less than or equal to or greater than or equal to. It includes the possibility that the bound is included. And it's bounded above by 100. Because the biggest it could get is 10 squared, which is 100. Right, now this actually is harking back to another problem we saw not long ago about the range of 1 over x squared plus 1. And we need to think quantitatively. It's exactly the same thing. What we're doing here is thinking about the possible values of 1 over x. And that's quite complicated, but we're restricting x to this. So what has to happen here is the following. At 1, this would be 1, and then as I get bigger than 1, I'd be dividing by something larger than 1. That's going to get smaller and smaller and smaller. Now, it can be as small as you want and positive, but it's never going to hit 0 because the numerator is always 1. So in this case, what do we have? This is bounded above by 1, because you start at 1 and then get smaller, and it's bounded below by 0. All right, this guy, much more difficult. Now, it looks incredibly similar. And it's certainly bounded below by 0, because 1 over x is always positive, right? So this is assuming x is in 0 to infinity. So this is bounded below by 0. What about above? So this is another moment that I think people can have misconceptions about, especially notation. So a lot of people here will say, but 1 divided by 0 equals infinity. Might be something you've seen in a calculus class or something like that. Now, that doesn't mean anything, right? 1 divided by 0 is meaningless. And if you think 1 divided by 0 equals infinity, it can be shorthand for something, but something quite sophisticated involving calculus ideas that you're going to study. So 1 over 0 equals infinity doesn't mean anything, right? Not really from a proper mathematical perspective. So what really is going on here? Well, what we're doing is, so you've got to really think carefully about this. We've got a number line, and we've got kind of 0 sitting here. And we've got my x, and you've got my x, and it's kind of moving closer and closer into 0, let's say, right? So what's going to happen as x gets close into 0? Well, I'm going to be taking 1 over x, and I'm going to be dividing it by something which is going to get smaller and smaller and smaller. So what is true is the following. 1 over x is going to get very big and positive as x gets closer and closer into 0. In fact, there's no bound on it at all, right? For example, if I want to have this over 1 billion, well then just choose x to be 1 over 1 billion, right? That small, so that close in. So there's no upper bound to this. If I'm allowing x to get as close into 0 as I want, this can be absolutely massive. So this is kind of a little bit of a precursor to ideas you're going to encounter in calculus, but this example is kind of a nice baby case of it. So this is not bounded above. Not bounded above. So it's a little bit of a difficult example, but it's good. It's trying to kind of hone your quantitative reasoning skills. So not just relying on graphs, thinking more carefully about what it is that your function is actually doing.